session I have. So by tomorrow morning, I will post the recording of this, and you'll be able to go back and review everything that was said between both you and I, and you'll see the screen that we're looking at in common.
Okay, great.
Now, that GoToMeeting control panel that's sitting on your desktop right now, you
Yes.
can minimize that. If you look up near the X, there's two arrows that are touching.
Yes.
That's a toggle switch. If you click that, it minimizes it and takes it near the top of your screen so that it doesn't take up so much of your screen. And then if you want to expand it again, you hit the two arrows again.
Okay, great.
Okay? Now, as far as the source of the problems, the way all my tutoring sessions work is I ask the student to bring the problems to the session. Usually it's problems you're working on in class, this week, or problems you want to go over in preparation for a test. Now, with pre-calc and trig, I would say most of the problems can probably be verbalized by you. So you just verbalize the problem, I write it, and then we solve it together.
Okay.
If it's a kind of a problem that is hard to verbalize, let's say they gave you a graph and they wanted to ask you where the vertical asymptotes or the horizontal asymptotes are, well, that's hard to verbalize. So for problems like that, take a picture of the problem with your cell phone and send it to my email address.
Okay.
Now, that might be something we'd want to get out of the way in this first session, just because it gets stored in your phone and it makes it much easier to do the second time. But here's the email address that you would want to send the picture to. Don't send it to my phone, because then I don't get it quite as quickly. But if you send it here and send it as an attached file, not as part of the text, the body of the text. If you're using an iPhone, send it as a large image, but as an attached file. Now, perhaps in this, half-hour session tonight, you have enough problems you could verbalize and you don't need to send me anything. And that's fine if you do.
Okay. I don't think I'm gonna need to send anything tonight.
Okay.
Most of the stuff is pretty easily verbalized. Not working with any graphs
Okay. Cool.
at the moment.
Let's try one.
Okay. Log base 3 of 8 times log base 8 of 9.
Wow. And are you allowed to use a calculator?
No, the directions are use properties of logarithms to find the exact value of each expression,
Okay.
and do not use a calculator.
Okay. Well, there's a problem here,
Yes.
and that is the bases are different. Are you sure it's log base 3 in the first one and log base 8 in the second one?
Yes, I am.
Okay. Well, are you familiar with the change of base formula?
I'm pretty sure we did this in class, but I do not remember.
Well, if I wanted to figure out what the log, in other words, what kind of calculator do you have? Is it a TI-84 or an Nspire?
Nspire.
Okay. Does the Nspire have just two log keys, a common log and a natural log?
Yes.
Which makes taking log base 3 tough even on a calculator. you would want to use the change of base formula. And the change of base formula is the log of 8 divided by the log of 3. And we're going to multiply that by the log of 9 divided by the log of 8. Okay, now we're getting somewhere. And this is common log in all 4 cases. Well, that log of 8 and this log of 8, I can cancel out. So now I have the log of 9 divided by the log of 3. Well, the log of 9 is the log of 3 squared, correct?
Correct.
So now we have that. And now I can take that exponent and stick it in front of the log of 3. So it becomes 2 log of 3 divided by log of 3. And the answer is 2. Do logs long enough and you see all kinds of problems. And this is, I have to say, this is one of the first problems I've ever come across where different bases are used. And they ask you to evaluate it. And so I was a little stumped at first, but as long as you use that change of base formula, it turns into something that works out pretty nicely.
Okay, great.
You're familiar with this property where the log of 3 squared is equal to 2 times the log of 3?
Yes.
Okay. And because we had to use that. And
Correct.
the only reason I saw it is because I could tell that I could write 9 in terms of 3 and then get rid of the exponent so that I'd end up with a log 3 in the top and a log 3 in the bottom. All right, what else you got?
The next one is 5 to the power of log base 5 of 6 plus log base 5 of 7. Oh, sorry, the log base 5 of 7 is part of the exponent.
Okay. Oops. What was it again? Log base
5 of 7.
Okay. Now we have 2 logs that have the same base and they're being added. Excuse me one second. Close my door here. So what does that become if I want to compress that into a single log expression?
Log base 6 plus log base 5 of 6 plus 7. So
Not
5 to the
plus 7, but 6 times 7.
Right, the properties.
Well, here's the property. If I have the log of A times B, that's equal to the log of A plus the log of B. So here we have the log of 6 plus the log of 7. That's going to be the log of 6 times 7. So this entire expression can become the log base 5 of 42. Okay, you with me?
Oh, yes.
Okay, now there's also a log property that says if I have b raised to the log base b of x, that's equal to x, always. So this is equal to 42. In other words, that part of it basically cancels out and you're left with whatever else you have.
Okay.
Okay? There's a couple of log rules that are kind of like this. Another one is, well, let's say I had the log I was trying to think of another example, but I can't really think of one. What's another problem you have?
E to the power of log base e squared of 9.
Really?
Yes.
Like that?
Yes.
Wow, I've never seen a base of e squared. Now, let me think for a second here.
A quick question.
Yeah.
If I'm writing this out, does it matter if I make the log a natural log or just regular?
It depends on what the problem says. Does the problem just say log?
Yeah, it says
I see what's happened here. Yeah, natural log is base e.
right.
If we're going to list the base, which is not e, it's e squared, then we do want to write it like this.
Okay.
As soon as I heard e, I immediately wrote ln, because that's usually what you write, and you don't write the base.
Right.
Let's see, how are we going to do this? Well, let's see. If we had to evaluate this expression, let's see what happens. Let's say we're going to let that equal to x. Well, what that means is that e squared to the x power equals 9, or e to the 2x equals 9. Not that that helps, because we still can't solve for x. Or could we? Let's see. We could take the square root of both sides, which gives you e to the x equals 3. Which means x equals the natural log of 3. In other words, when I get to this step, let me make sure you can follow each of these steps here. I'm trying to evaluate that expression, okay?
Right.
I let it equal a variable, just because it makes it easier to think about.
Mm-hmm.
Once I have that log equation, I can say this number raised to this power is equal to 9. So I've got e to the 2 raised to the x equals 9, which becomes e to the 2x equals 9. Now I take the square root of both sides. That gives me e to the x over here, gives me 3 there. Hold on. Come on, Billy. And now, if e to the x equals 3, and I take the natural log of both sides there, and I get x alone on the left equals natural log of 3. So, since that was equal to x, I can replace it with natural log of 3. Now I can solve it. E to the natural log of 3 is equal to what? This goes back to the rule we used on the last problem also.
Would it be 3?
It is 3, exactly.
Okay.
Because it's b to the log base b of some number. And that's equal to that number right there. Wow, these are very challenging. I mean, I've been tutoring logs for 6 years and I've never come across problems like this. Is this an honors class?
No.
Really?
Really?
Not an honors class, and they're giving you problems like this. Interesting. Okay, what else you got?
E to the power of ln of 8. Oh, so it would just be equal to 8 then?
You got it.
Okay. All right.
What else?
So the next section has a different set of directions, and
Okay.
the first problem is log base A of u squared times v cubed in parentheses.
All of that in parentheses like that?
Yes.
Okay. So we're going
And
to separate this, and it's asking you to separate it, right?
it's saying write each expression as a sum and or difference of logarithms.
Right.
Express power as
Well,
factors.
this goes back to this statement here. There's 3 log rules. Let me list all 3 log rules that are critical when dealing with logs. Okay, number 1 is log of A times B is equal to the log of A plus the log of B. Number 2 is the log of A divided by B equals the log of A minus the log of B. And number 3, the log of A raised to the B power is equal to B times the log of A. This A I'm using is not the same as this A over here. I could have used
Right.
X and Y for that matter for my 3 rules. So the first thing I'm looking at here is the product of a couple of things, right? So
Yes.
I can immediately turn that into log base A of u squared plus log base A of v cubed. And now, using rule number 3, I'm going to take these exponents and put them down in front of the log. So this becomes 2 log base A of u plus 3 log base A of v. Now, all 3 of these rules over here only apply if the base is the same.
Right.
If I had log base 4 here, and these rules, incidentally, they're going to ask you to go both directions. It's not that you just need to know how to separate, it's also you need to know how to condense. In other words, they may give you an expression log of 3 plus log of 2. Well, if you put that back together again, that becomes the log of 6. See that?
Yeah.
Okay. Well, there's just as many problems where you have to put them back together again as there are where you have to separate. They usually give them to you in two sections. One section will be separated into multiple logs like this one is, and the next section will be put it into a single log expression, which is going from right to left on these rules. But this is your answer for this one.
Okay.
And notice we have the sum of 2 log expressions. Okay, you got another one like that?
Yeah. This one, it's more complicated. It's the same directions, but it's log, just base 10, of bracket x times the quantity of x plus 2, all divided by x plus 3 squared, and end bracket.
Okay. Again, we have multiplication going on in the numerator, and we got division going on with a power. So the first thing we're going to do is to break this up into 3 log terms. Okay? So what's the first term going to be?
Log of x.
What's next?
log of x plus 2.
plus the log of x plus 2.
Right.
Very important. In other words, we're multiplying on the inside of the argument here, but we're adding two different log functions here. And how do we handle the bottom, the denominator? When you're dividing, that's the same as subtracting.
Right.
And I leave the squared. And now, applying that third rule of logs, I can bring this 2 down in front and stick it right there. Get rid of it there. And that's fully expanded.
And is writing minus log of x plus 3 squared, is that the same as writing minus log of x plus 3 2 times? Or no?
Yeah, it basically is, yes. In other words, I think this is what you're asking. Is this the same as
Yeah.
And
Yeah.
it is. In other words, if I expanded that, I could have written that log of x plus 3 times x plus 3, right?
Right.
Okay, and then I separate it into these two. But now notice what I have. I have one log of x plus 3 plus another log of x plus 3. What is that? That's 2 log x plus 3. Which you get quicker by merely moving that 2 down to there.
Okay.
Okay, so that rule where you take the exponent and bring it down onto the algebra line out of the exponent is probably the most important of those 3 rules. We use that rule a lot in calculus and logarithm equations in general. Okay, the key here is everything that's being multiplied in the numerator is going to be added. Everything that's being divided is going to be subtracted.
Okay.
So even when you have a really complicated expression like this, in other words, what I'm saying is this. If I have the log of x times y divided by z, that is the log of x plus the log of y minus the log of z.
Okay.
And that's kind of what we have, only instead of x, y, and z, we have x, x plus 2, and x plus 3 squared.
All right.
And it's probably best to do these steps one at a time. In other words, you'll notice the first step, I left the 2 as an exponent, and then in a completely separate step, I bring the 2 and stick it in front of the log. But
Okay.
you have to do all the way to that step to fully expand it.
Okay.
Okay, what else you got?
Um.
I would think you probably have a few where you're asked to condense them also.
Yeah. Just the opposite.
At least one of those, because we don't have that much time left.
Okay. Natural log of x divided by x minus 1 plus natural log of x plus 1 divided by x
That it?
minus
Oh, go ahead.
minus natural log of x squared minus
I didn't quite hear that the argument part.
1. X squared minus 1.
Okay. All right. So we have the sum and difference of a bunch of logs. We're going to put it all into one natural log. Okay? What I'm going to do is multiply that by that. What do you get? The x's cancel and you end up with x plus 1 over x minus 1, right?
Right.
And then I'm going to divide, then I'm going to divide all of that by this x squared minus 1, which factors into x minus 1 times x plus 1. Okay. So now I've condensed it, and that's all I need to do is simplify what's in the argument. But you see how I got everything?
Yeah.
Okay. Now to simplify this, I'm going to flip this and multiply. So it's the same as x plus 1 over x minus 1 times x minus 1 times x plus 1. See that? Why it's the same? Oh, excuse me, that's in the denominator. Yeah, sorry.
Oh, gotcha. Yeah.
In other words, there is, let me rewrite that. In other words, there's an implied 1 on this bottom fraction here. So when I flip and multiply, I'm multiplying by 1 divided by x minus 1 times x plus 1. And I factored it because I knew I was going to be able to cancel some stuff. So that x plus 1 cancels with that x plus 1, and you're left, the final answer is natural log of 1 over x minus 1 squared.
Okay.
Now you might ask, can I do anything with that too? Well, actually you can. In other words, I can also write that as natural log of x minus 1 to the minus 2 power, right? The same number. In other words, 1 over x minus 1 squared is the same as x minus 1 to the minus 2. Now I can bring that minus 2 down because it's an exponent. And there's my answer. This should be the answer that if they gave you answers, that's what you should find.
Okay.
It's all about using those 3 rules and either compressing or expanding.
Okay.
Logarithms is how a slide rule works. In other words, on a slide rule, if I want to take the natural log, if I want to multiply 17 times 16 on a slide rule, what I'm going to do is I'm going to take the log of 17 and add it to the log of 16. And my slide rule has a log scale on it. So it immediately gives me an answer. And that's how slide rules work, is by using those 3 principles of logs.
Okay.
Okay. Hey, we got time maybe for one more, if you want to do one more.
Yeah, for sure.
Go ahead.
8 log base 2 of the square root of 3x minus 2 minus log base 2 of 4 divided by x plus log base 2 of 4.
Okay. I could actually turn that into a number real quickly. What's log base 2 of 4 equal to?
2.
Right. But I don't have to. We'll use the rules of logs. First thing I'm going to do is get rid of that radical sign, because exponents are key. So I'm going to change that to the 1/2 power. Okay?
Okay.
Now I can bring that 1/2 multiplied by the 8, so this term turns into this.
Okay.
Since I am subtracting this, then I could combine those two terms and put this in the divisor. So if I had the log of 3x minus 2 divided by 4 over x, that would be the same as the log of that minus the log of that.
Okay.
Okay? And then finally, I have 4 as a multiplier in the numerator, that third term.
Right.
Well, now if we flip this and multiply, we have 4's cancel. I end up with x times 3x plus minus 2. And you probably want to multiply that out. So it becomes 4 log base 2 of 3x squared minus 2x. And if you want, you could even take that 4 and stick it up there. And that's your answer. The single log expression.
How did you get the x on the bottom denominator times 3x minus 2?
Okay, because I'm subtracting these two log functions, then it's the same as that as a single log function of that divided by that. That's how I got this step right here. There's my single log function, and the division is 3x minus 2 divided by 4 divided by x. So now I flip and multiply, and that 4 cancels out with that 4. But I still have an x in the numerator that I need to multiply the 3x minus 2 by.
Okay.
And that's how I got 3x squared minus 2x.
Gotcha.
And as to whether I put the 4 as the exponent or leave it in front, I don't know. I'm not sure how far they want you to compress it. They probably want it compressed to this level here, is my guess. But I doubt that you'd lose points if you gave that as the answer. Well, you certainly would want to multiply those two together, always.
So having it as the exponent versus in front of the log, the exponent is, quote, more compressed?
I think so, yeah. When you're compressing, you're pretty much going the other direction. If I was expanding, then I would immediately put that 4 in front. So, yeah, I guess on second thought, that's probably almost certainly the correct answer.
Okay.
For condensing. Ultimately, you're going to be solving log equations, and then it doesn't really matter what you do. You're going to end up solving for x. I mean, it doesn't matter whether you leave the 4 down here or put it up as an exponent. In terms of condensing a log expression, perhaps it matters. It's better to have it as an exponent. Just like if you were expanding this, if this was the problem and they said expand it, well, the first step I would do is bring that 4 down and stick it in front. Then I would factor out an x so that I had two things multiplied by one another. And then I would expand it into two log expressions.
Log base 2 of x plus log base 2 of x minus 2?
That would be 3x minus 2. In other words,
okay.
If I factor a greatest common factor there, it's x, and what's left over is 3x minus 2. Okay? Now let's put 4 is out front like that. So now I have the log of two things being multiplied together. So that's going to become 4 log base 2 of x plus 4 log base 2 of 3x minus 2. So if I was taking it apart, this is how I would do it. And even though it doesn't look exactly like what we started with, it actually is. In other words, if I want to make that to the square root, I can turn that into an 8 to get
Right.
back to exactly what we started with. Okay. William, that should give you an idea how the online sessions work.
Okay.
It's always about me asking you to tell me how to do the problem rather than me just explaining it. In other words, I have very few sessions where I talk the whole time. The best sessions of all are where you talk the whole time, really, because that means you're doing the problem. And that's when you really learn math, is when you do the problem, not when you listen to somebody else do the problem. You know what I mean?
Yeah.
That's where learning really takes place. Passive learning is where you listen to a teacher lecture. Passive learning is where you read a book. Active learning is where you do the problems. And it's active learning where you learn the best. So maybe you don't know how to do a problem, and I'll tell you the first step, and then hopefully you know the second step and the third step and so forth. But that's the way my tutoring works.
Okay.
Okay?
Okay.
Now, you've figured out how to schedule appointments online, so you know how to go to my website and do that.
Yes.
If you want to schedule another appointment on your own, that's fine. You can pay one of two ways. You can pay through my website using PayPal,
Yep.
or you can send me a check. I don't care. As long as you live locally, I'm fine. I live in King Carl.
Oh, yeah.
I end up with a lot of Ralston Valley students. And most of them I end up working with online because I live so far away from where they do. But the online actually works just as well as in person. You don't really lose anything at all.
Okay. So we'll get a couple sessions a week scheduled. I'm assuming an hour would be much better than half an hour. Is that right? Or are your online sessions only
It
half
kind
an
of
hour?
depends on his attention span. In other words, I went to half-hour sessions because I found that when I did hour sessions with students, I would start to lose them at about the 45-minute mark. I would lose their focus. They'd start looking at the clock, their watch, anything. When is this going to be over? So I generally tell people that if they want to do an hour session, they're probably better off doing 2 half-hour sessions. The cost is the same.
Yep.
And you get their full attention for the entire hour that way. And it all depends on William. If he has no problem giving his attention and focus for a full hour, then hour sessions are going to work out fine. And in fact, they're probably going to be a little better because when he takes tests, they're probably an hour in duration. So he needs to build up a little bit of mental endurance to take a test. It's
Okay.
like if
So why don't we do this? Why don't we do half an hour one day and an hour another day to start?
Sure.
Let's see how. Is that okay?
That's fine with me. If he feels like he needs that much, I'm happy to give him as much as he needs.
Yeah, I think we do. We moved here from Chicago, and so he's new into this school system here, and he's been kind of struggling, so this will be really helpful.
Okay. Sounds good. We'll get him caught up, for sure.
That's what we need. Okay, well, thank you very, very much. I'll get that scheduled online right away.
You're welcome.
Thank you very much, Mr. Panama.
Do you go by Bill or William?
William.
William?
Yes.
Okay. William, I'll talk to you next time.
Great. Thank you very much.